Here we are on a walk-in freezer service call. Looks like it's got some ice buildup. We're gonna go ahead and open up the electrical panel. I have the management moving some product for me right now, so we're gonna get in here and check out the electrical situation and look at the defrost heaters. At the defrost clock. Don't see anything jumping out at me yet. Definitely some buzzing coming from that contactor. So what I'm going to do is go ahead and initiate defrost. Should be going into pump down right now. One in neutral. It's got 208, which is correct. Now between neutral and 3, we've got no voltage. Neutral and 4, we've got no voltage. And actually, now that I look closer, I don't know if you can see that or not, there's actually a melted terminal on number 3. So it's not initiating defrost. Back of the clock, if you look right there, you can actually see some pitting going on. Right in here. I shouldn't say pitting, but it's a melted contact. And what's happening is right here, we're not making contact when it goes into defrost. So they're down there moving product. So what I'm going to do is I'm going to go ahead and replace this defrost clock really quick, and then go ahead and fire up the heaters so that way it can defrost while they're moving the product. And then once they get it all moved out of the way, I'll bring a water hose in there and melt it quick style. So I got a new clock here. As you can see right here. On that other one, I'll show you, but that's the terminal that's melted. You'll see the difference here in a minute. nothing melting in there. And look up here on the front. You can kind of see how it's distorted and it's not making contact. Something I don't understand is why anybody still uses a flathead screw. It drives me nuts. If that was a Phillips, it would fit right in my screwdriver and I could push it right in. $1 million idea. Have someone make this defrost clock with a magnetic top screw. Make a lot of service guys happy. Okay, so this is a basic walk-in freezer with a basic electrical heat system. 208 volt power goes to 1 in neutral of the clock. That powers the timer motor and then applies power to the common terminals of the switching relays or switching contacts. So 1 in neutral's power. Notice that 1 is got a jumper bar right here to 2. 2 is your common for 3 and 4. So neutral and 4 will have power in normal mode, refrigeration mode, and neutral and 3 will have power in defrost mode or the switched mode. And then you have a timer release solenoid on X. So that way, if the evaporator coil gets too hot, we have some safety switches down inside of it that will send power back up on the X terminal. Make this plunger go boom, and notice I just clicked it out of defrost. So that's exactly what it does. I'll show you that again. So we'll push it into defrost. So in normal, it's in defrost right now. And if we brought power back up on X, this solenoid would suck, or this solenoid right here would suck this little push rod up into it and push the unit out of defrost. And you can see the mechanical action right now. Boom, just clicked out of defrost, even though it's still saying defrost. So this particular system is a time and or temperature termination. Temperature coming up on the X terminal, time using the timer motor. This one's set up for a 28-minute defrost. That's pretty typical on these systems that I'm working on. Got to make sure you change it from the factory to what you need it to. So we're 28-minute defrost, and I'll go ahead and put my 4 defrosts in there real quick. What I'm going to do is I'm going to harvest the defrost pins out of the old clock. That way, if we ever run into a weird situation where you need more than the 4, we've got extras, because it comes with 4 of them. But I'll leave those ones there and put these extra 4 in. Some customers want their defrost to be at an exact time. This particular particular customer, it doesn't matter, just so long as it doesn't ice up. So it doesn't really matter where I put the times. And theoretically, if you knew they had a problem of a real busy time going in and out of the box, you might make the defrost not happen then, you know. This one should be fine, doesn't really matter. Just so happens that I'm putting them at the same time as the other one anyways. Didn't realize that, it just kind of happened by chance. Okay, so alright, we'll go ahead and turn power on. So in order to check it, I'm going to check to see that we have 208 volts between 1 and neutral. 2. Now I'm going to leave one leg on neutral and check from neutral to 4. We have power, which is correct. That's refrigeration mode. And then I'm going to switch from neutral to 3. We should have no power. That's defrost mode. So now I'm going to twist the timer. We're in defrost now. We have 208 volts going to the defrost heaters, and I'll go back to neutral and 4 and we should have 0, and that's correct. So refrigeration mode is not being powered, and then neutral to 3 now has 208 volts. Now another really important thing in here is if you notice that I've got 2 contacts in here, well, this is my defrost contactor and this is my compressor contactor. Doesn't always happen this way, but we actually happen to have an auxiliary relay right there that won't let this contactor engage until this contactor disengages. So that's what that auxiliary relay is for. So I don't know if you noticed, but now I saw this one pull in, and you can check across it, and we've got 0 volts, and I know we've got voltage going into it. So I can simply put my amp clamp right on that wire right there. We've got 10 amps because that's the defrost heater circuit. So we're going to let that run while they're still moving boxes, and then I'll start getting my tools ready to defrost that coil. Also, this is a good thing to do if you're coming out on an iced up walk-in freezer. It's actually better to check the heaters when it's frozen up, because think about it, if I go into there and defrost that coil with hot water and then go to check the heaters, well, it might be warm enough to terminate the defrost by sending power up to the X terminal. So I always say to check it when you first get here. Come up onto the roof, you know it's iced up, flip it into defrost and see what happens, because this is the perfect time. It's iced up, so that coil is at least 32 degrees right now. So that's what we did. It was iced up, flipped it into defrost, found that the defrost wasn't working. You could do it the other way. You could defrost it first, but you're gonna have to wait for that coil to get below 20 degrees after you defrost it. So it's just, you know, you could save a couple minutes by checking the defrost before. Now, just because I see 10 amps on there doesn't mean that every heater is working in that coil. Usually there's 3 to 4 of them, or maybe even 5 or 6, it just depends. So I just know that my defrost clock is working now. I don't necessarily know that all the heaters are working, so that I will have to check downstairs. So I've actually gotten to a pretty good routine of doing these. I get a lot of iced up walk-in freezers, so I kind of have a little set way that I'm used to doing them, and kind of become pretty easy. I shouldn't say easy, but I definitely have a routine. You know, I know exactly what tools I'm going to need to bring in here, especially depending on the type of walk-in. If it's a heat craft, I need a wrench to take the fans off. If it's a cold zone or a Russell like this, I know the particular things I need. Now when I do this, I'm going to take everything out to defrost it. But like I told you before, we're going to test all the defrost heaters first. So what I'm going to do, bring it over here and show you guys my electrical cabinet. Pay attention, this is one defrost heater right here. For the people that don't know, it's not 2 heaters, so I only need to amp one of these 2 wires right here. But then there's another defrost heater right here, so there's actually only 2 total heaters on this unit. So all that I need to do is check the amperage. There's 5 amps on that one, and then just grab this other one. There's 4 amps on that one. So all the defrost heaters are working. So we're good. So I'm going to be very careful about this, but I'm going to leave the heaters running while I'm taking everything apart. Again, once I get to the electrical and the fan motors, I'll shut it off, because unless I can do it safely, disconnect it. But might as well. The fans aren't going to turn on for the moment. I mean, I guess it's possible that they could temp out, but not very likely right now. Bring a little pan, throw my screws, simple things. Me personally, I like to completely take out the fan motors, fan blades, and everything. If it's a walk-in cooler, they're usually really dirty. The walk-in freezers, they don't get very dirty. They're typically not in and out as much. So this one, it's got quick connects. I'm gonna be able to get in here and just pull this thing apart real quick. Power off. And again, I'm kind of OCD, so I do things a very particular way. I like to be most efficient. I sweep from the top down, not focusing on the bottom, because the heat and hot water from the top are going to go down. All the time, I'm not letting any water drip out of the pan. If it starts to overflow, you stop. The walk-in freezer, you don't want to get water all over the floor. Even a cooler, but cooler you could. Walk-in freezer, you're not going to get it all up. It's going to freeze, expand, and cause damage. I'm waiting for this water to get hot. Hopefully it's just because it hasn't cleared the hose yet. Second, start to get pretty full. Let it drain out. Good sign that there's no ice in the drain pan. That could be a problem. Just water. Even just the drain nipple in the back. I'm just watching that nipple hole and then making sure it doesn't go too high on it, and when it does, I just let it drain for a minute. So these are the limit switches. Here's one right here. Here's one, and here's one. This one has 3. Sometimes they just have 1 or just 2. One of these is going to be a fan delay, one of these is going to be a heater safety, and one of these is going to be a defrost termination. At this point, I'm going to go ahead and assemble everything, and then we'll go from there. So I'm back up on the roof. I got the unit all put back together. What I'm going to do is, because when I got here this contactor was chattering really bad, I'm going to go ahead and replace that contactor the auxiliary relay, and the defrost contactor. The new one I have is going to be a little bit different, but it'll work the same. That's the new one that I have. It snaps onto the side. You could do normally open or normally closed. Screws there or screws down here. And then it's just a 208 volt contactor. So the action of this basically works with that mechanism right there and pulls this thing down. And then unfortunately I don't have a single pole contactor, so I'm going to try to wedge a 3-pole in there if I can. Okay, nice and snug, nice and snug. So, this guy should go to the coil. On this guy. It's not working. Guy should go there. Making sure that that's correct. That should be going down. Yeah, that's correct. Okay, cool. So now should be able to turn this on. It's pumping down right now. And this one just pulled in when this one pulled out, because we have So what we're going to do right now, this thing is set for a 28-minute defrost. We're going to make sure that the limit switch works. So we're just going to let it run in defrost right now, because that coil should be nice and warm, so it shouldn't be running very long. So yeah, I went downstairs. It's not really something I could show on the camera, but the defrost termination switch is bad. So like I said in the video earlier, you got 3 switches down there instead of just one that does it all. You've got a heater safety control that just kills the power to the heaters if it gets too hot. That's wired in series with the heaters with one leg, so it just disconnects a leg. Then you have a fan delay that turns the fans on and or keeps them off if the coil's not cold enough. And then you have a defrost termination switch. The defrost termination switch, once the coil gets to a certain temperature, it sends power up to this X terminal and clicks that solenoid over. And that's not happening. That coil is really hot right now, and it's not terminating. Another way you could check this too, because I just got done defrosting that coil, so I haven't even turned it on yet at all. And after you get done defrosting it, if you put it into defrost, most of the times it should click right out via the termination switch. So I knew something was up right away, but this one has been running for a good 10 minutes on heat mode, and that coil's nice and warm. Should have terminated by now. So on the switch itself, it's what I thought it was. The top of it's swollen out. So I'm gonna go ahead and put this back together. They can operate right now. It's just gonna do the full 28-minute defrost every time. So that's probably why, part of the reason why that thing had been getting so hot. It's probably just so many amps running through that, and it probably had a loose connection, so